Hello, everyone. Welcome back to the Intro to C course, MCS 1142. Today is week 03B, which is the fifth session out of 20 sessions for this summer semester 2021. Today is the first session of the third week. According to the syllabus, we are going to be learning and going over chapter 3. So June 1st, 3A, chapter 3, which is a structured program development in C. So in this chapter, we will learn basic problem solving techniques, and we will learn how programs flow, the top-down process and stepwise refinement, how to step into your code statement by statement. We will use the if statement, and moreover the if-else statement. And we will use while iteration. We will learn about while loops, while iteration statements, or while loops. In addition to that, we will use counter-controlled iteration, and we will see the difference between counter-controlled iteration and sentinel-controlled iteration. And finally, we will learn the increment, decrement, assignment, and relational operators. As a matter of fact, we will do relational operators first, and then we will go over chapter 3. But before I proceed, I would like you to do a simple change in your Visual Studio, just so we match the code in the book. So if some of you students are following the code exactly as is in the book, you're gonna have some errors, because eventually Visual Studio updated its version, but the book is not updated. So in order to ignore this error, I would like you to do this. So now you can pause the video, read these, and do it in your Visual Studio, but I'm gonna do it here anyways. So project properties, configuration properties, C, C++, preprocessor definitions, and add the following macros. So I'm gonna copy. I'm gonna go over to project properties. So I go here, I go to project properties, and then I go to configuration properties, which is selected already. Then I go to C, C++, preprocessor, and then preprocessor definitions. So here it is. Make sure you are on the active configuration. For example, I am building debug x64, so I'm gonna choose whatever the active. Now, if you want to do it for all configurations, you select all configurations. For now, I'm just gonna build as debug. If I have it in future, I'm gonna make sure to change it as well here. So I double click. Actually, I go to this arrow and I say edit. And then I click after console, I hit enter, I paste, and then I say, okay, apply, hit OK. So now when I build with the scanf, I no longer get an error. So build. So now my code or my Visual Studio matches or will not error on the code that is coming from the book. So with that being said, next thing I want you to learn about is the relational operators. I'm gonna open Paint again. What are relational operators? So I'm gonna say relational operators between parentheses assignment. Not assignment, equality operators. This you need to memorize. So there are a bunch of operators. First one is less than. Let's make it bigger. So less than, greater than, less than or equal, greater than or equal. Then you have the equality operators, which is under the umbrella of relational operators. Equal, equal, and not equal. So these fall under the umbrella of relational operator because they will check the relation between one variable from the left to the second variable on the right. So what's the relation between these two? Are they equal or are they not equal? These relational operators are used in if statements, and if statements go like this. So we have if, parentheses, and then we have a condition. And we're going to learn about this more in details. This condition, if this condition evaluates to true, then anything inside the if statement will be executed. On the other hand, if this condition evaluates to false, then the body of the if statement will be ignored. So it's a code that you type, you say if some condition, then you have a body. If this condition, whatever I put here is true, evaluates to true, then this body will get executed, no matter how many lines I have, whether I have one line or many lines. If this condition doesn't evaluate to true, means it evaluates to false, then the entire body will be ignored. So the control will come to this statement. It's gonna check, hey, is this true? If yes, then the control will start executing these lines. If it evaluates to false, the control will jump all the way to line 36 and will ignore the entire body. So back to the paint. Less than is checking if the number on the left or the variable on the left is less than the number on the right. Is this true or false? And it will take an action based on that. Greater than will check if the number on the left is greater than the number on the right. Then we have less than or equal, greater than or equal, which is defines itself. Then you have the equality operator. Now, don't confuse this operator with the equal operator. This one equal character, one equal symbol, like here, this is an assignment operator. So this is assigning the value of this operation to this variable. But on the other hand, the equality operator is two equals. So here I'm going to say, for example, if sum equal 10, then I'm going to say print f sum is equal to 10, semicolon. So let me execute. Enter the first integer 5, enter the second integer 5. Then sum is equal to 10. So the control executed this statement at line 20. And then it jumped to line 22. It checked, hey, is sum equal to 10? Is this true? Then yes. Since sum is 10 in my case, I entered 2 5s, then this line got executed. For example, if I rerun my program, but I give it a value that doesn't evaluate to true, so 5, for example, and 6, notice the program did not print this line. So the control came to this if statement and evaluated this condition. Is this true? And it turned out it's not true. At that point, sum was equal to 11, so this line didn't get executed. The entire body got ignored. Same case for the rest of the operators. Not equal 10. So if sum is not equal 10, then I'm gonna print sum is not equal 10. So I'm gonna put 5. I'm gonna make it evaluate to true. So I'm gonna make it evaluate to false. So first integer is 5, second integer is 5, sum is 10. So it got ignored. Why? Because sum is not equal to 10 evaluated to false. Sum was in this case equal to 10. So if sum is not equal to 10, then print. But since sum was equal to 10, it didn't execute. Same for greater than. So I have greater than, then I have greater than or equal, then I have less than or equal. So less than and less than or equal. So sum is greater than 10, sum is greater or equal to 10, sum is less than 10, sum is less than or equal to 10. And here I'm gonna just display some new lines. So go. Let's give it a value of 10. Two statements will be two sentences will be displayed. Sum is greater or equal to 10, which is correct, and sum is less than or equal to 10, which is also correct. Because since sum is 10, so both statements evaluated to true and the other two sentences evaluated to false. So two sentences were ignored and two sentences were displayed. So let me put a line here, and line here as well. Now let's give it greater than 10. So I'm going to say 5 and 6. In this case, sum is greater than 10, which is this line, first line, which is true. This evaluated to true, but also the second sentence also evaluated to true because sum is greater or equal to 10. So these are called relational operators. And this is called if statement. Now I'm going to go over if statement in details, but let me go by the pace from the chapter. So now that I explained the relational operators from last chapter, I'm going to go with the book. So what does the book say? The book starts with algorithms. It's defining some topics for you before we jump into the code. So I'm going to remove all these for now. And it's saying what is an what is an algorithm? So an algorithm is a procedure. This is the definition when you get asked on in test. So what is an algorithm? You're gonna say any. You're gonna say any computing problem involves executing a series of actions, right? In a specific order, which is very important. So an algorithm is a procedure. It's a procedure. It's a group of tasks. It's a procedure for solving problems in terms of actions to be executed. And let me maximize this for you. Oh, that's too much. Actions to be executed and their order. So the order of in which these actions are to be executed. Boom. This is called an algorithm. So what is an algorithm? An algorithm is a procedure for solving problems, and it's a relation between actions to be executed and their order. The order matters. It's very important what needs to be done and the order of those tasks or instructions. So correctly specifying the order in which the actions are to be executed is very important. For example, let's take a real life example. Let's say you are you wanna buy an energy drink, right? And assume you just arrived to the gas station. We're not gonna go into details into getting out of your bed, jumping into the car, drive, etc. So assume you just arrived to the gas station and you want to buy an energy drink. So what are the actions that needs to be done and what is their order? So the actions that needs to be done. First, you get out of the car, right? Second, you lock the car. Third, you walk to the door. Fourth, you open the door. Five, you grab the energy drink from the refrigerator. Six, you pay. Seven, you walk back to the door. Eight, open the door. Nine, walk back to the car. And finally, 10, you take off. So there are bunch of actions that needs to be done and their order. Now, suppose we keep the actions or the instructions, but we change their order. Let's say you just arrive, you get out of the car, you lock the door, and then you grab the juice. So so you're gonna hit the door face first, right? Because you need to open the door before you walk in. So if you do the grabbing of the juice before opening the door, that's gonna be a problem. So this is why this is why the order really matters. Specifying the order in which statements are to be executed in a computer program is very important and is called program control. This is how the program is controlled, or this is how you control your program. You define the actions that need to be done for solving a problem and their order, which comes first. In Visual Studio, it's top-down execution. So it's this is first, this is second, this is third, this is fourth, and you probably know by now. So what's an algorithm? It's a procedure, it's a relational, um, it's a link or relation between bunch of actions and the order in which these actions are to be executed. Next thing they need you to know is a pseudo code. So pseudocode is exactly what I just said earlier. It's an English-like language that helps develop an algorithm. So 1, you do this. 2, you do this. 3, you do this. No matter which language you are. Back to the example for grabbing an energy drink. No matter the language you speak, no matter the country you are in, those steps are gonna be the same exact actions that need to be done if you wanna go and buy an energy drink. No matter what language you use, no matter what platform you are on, the algorithm is gonna be the same on in any programming language, in any platform. So the pseudocode is this artificial and informal language that helps you develop an algorithm and communicate the algorithm, right? If someone doesn't speak your language, asks for that, or someone uses a different programming language, asks you to show him how did you solve the problem, by sending him the pseudocode is gonna be easier for him because he doesn't use your programming language. So if you send him the code of your language, he's not gonna understand it. So a pseudocode is an artificial and informal text or language that helps you develop and communicate algorithm. Now, you need to keep in mind pseudocode is not a programming language. It's not a programming language. It is, on the other hand, informal and artificial language that helps programmers develop and communicate their algorithms. Let me show you an example. So an example would be, let's go in here. So pseudocode example. I'm gonna go here because it's just faster than me typing it. Now notice how it goes top down and it's language agnostic. Language agnostic mean it doesn't matter the language. It doesn't matter which programming language you use. in order to solve this problem, you always do these tasks. So program start, initialize variable A as 0, then initialize variable B, then start an infinite loop, then call function segment convert within input A, with input A, with input A. Oh, seg convert returns the value. So seg convert is a function. So call this function and receive a value. Seg convert will return the value B, display it on the LED port, increment A, and check, is A greater than 9? If yes, then set A back to 0, call the function, delay for 500 milliseconds, now end the infinite loop. So if I'm your manager, right? And I grab this piece of paper and I have 10 employees, one that writes in C++, one that writes in C, one that writes C#, one that writes JavaScript. And I say, hey team, here is a piece of paper for each of you. It's the same piece of paper. I want you to build me a program that does just that. Then each one of you will grab that piece of paper, will read this pseudocode and will be like, oh, okay, I know what you want. Goes on his desktop, his keyboard and start typing his code in the language that he knows, then deliver the program. So this is a pseudocode, and this is the definition of a pseudocode. The next thing in the book that they need you to learn is, first, I'm gonna, before I, if you wanna take a print screen of this, pause the video, take a print screen, then I'm gonna go all the way back to my program, because I need you to learn about stepping into the code. So let me greater than, let's say, let's stay in greater than. Save, 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 save. So you see this gray column? This is called the breakpoint column. If I come to this line, line 11, and I click here, notice I have a red point. It's called the breakpoint. So I want a breakpoint at line 11. I would like a breakpoint at line 17. I would like a breakpoint at line 22. Now I'm going to execute my program. And notice the program didn't run. The program stopped at line 11. Why? Because I put a breakpoint. Now notice in my breakpoint, I have this this yellow arrow. Yellow arrow means the control is right now here. So the program is right now at this line, waiting for my input. What are my inputs? My inputs are going to be step into or step over. These are the two keywords, and you can find them here. So I have this step into, I have this step over. F10, F11. You're most likely going to use F10. Maybe every 10 F10s, you're going to use one F11. What's the difference between step into and step over? Remember that we said this is a function that the program is calling and giving it an input. Then this function is going to go and do something under the hood. Step into means I want the control to go inside that method. I want to dig in this method and see what's happening inside. Now, on the other hand, step over means jump to the next line. So between line 11 and line 12, there is this displaying that is happening. When the control jumps to line 12 means done executing line 11, I'm going to see stuff on the screen. So something happened under the hood. I could go back, rerun the program, and stop at this line and then step into printf to see exactly what's happening before it displays on the screen. So I'm going to use my keyboard, or actually I'm going to use this on the display just so you see it. In this case, I'm going to step over. So my program is here waiting for me, and I'm going to go click F10, step over. Now notice the arrow jumped to line 12 means the control right now is on this line. So if I go to my screen, and I'm going to notice that line 11 has been executed. It executed and it displayed this line. So now I'm at this line waiting for me to decide what would you like to do. Well, I would like to also step over. So now it stepped over and waiting for me to put an input. So I'm gonna say 5. Boom. So now the control is on this line. What would you like to do? Would you like to step over? Yes, I would like to step over. Boom. So now the control is at line 15. And notice you have all these helpful displays. So call stack, you probably are not gonna use call stack. You're probably gonna use this autos because it tells you what each of these variables is right now holding. So for example, integer 1 right now is holding the value 5 and is at this memory address. On the other hand, integer 2 right now is at this value at this address. So this value is a junk value, is garbage. So whenever you declare an integer and not give it a value, it's gonna hold some garbage value. And it's called like the default value of an integer. Why it's junk? It's a junk. They gave it a junk value just so they don't give it a meaningful value. Like if let's say the default value of an integer is 10, you're probably gonna confuse it like, hey, 10, was it a default value or a value that the user entered, or a value that we received with from the stream, or a value that the user entered? So 10 is a little confusing, but a garbage value like this one is not going to be confusing, right? What are the odds that the user or you as a programmer ask the user to enter this specific number? That's what I think. So now the control is at scanf. I'm gonna step over. It's gonna wait for me, asking what's the next item, what's the next input. I say 5, I hit enter. So now the line is at 18. Notice that sum is garbage. So now if I hover my mouse, I forgot to mention that you can hover your mouse and you can, and it'll tell you what each value, what each variable is holding right now. So now sum has been declared, right? I declared at line 17, I declared an integer, gave it the name sum. I didn't give it any value, so it holds the garbage value. So now at line 18, I'm going to assign a value to sum. What is the value that I'm going to assign it to? As I'm going to assign integer 1 plus integer 2. So if I step over, boom, now sum has the value 10. Why? 5 plus 5, 10. It's going to print. Step over, it printed the sum. Now I am at if statement. So sum is 10. Is sum greater than 10? No, false. Since it's false, notice the control is gonna ignore this part. It's not gonna step into the block. It's gonna jump out of the block. So it's gonna jump from 2022. So it's gonna jump from 22 to 29. Step over, boom. Why it ignored? Again, because sum is not greater than 10. Sum is equal to 10. So this is step into and step over. Once we start learning and doing functions, we're going to see how step into works exactly. Because right now, if you jump to printf, it's pretty mess. It's a messed up code. So let's not do step into right now. Stop. So this is step into and step over, and they call it, what did they call it in the book? Control structures. Control structures. The next thing you need to know is flowcharts. Flowcharts are similar to pseudocode. So pseudocode is an English text that communicates and helps you develop and communicate the code. Flowchart is a design that helps you develop and communicate a code. And it has 4 main shapes. You have the square, you have the diamond, you have the equal square. So you have a rectangle and square. So you have a rectangle, diamond, square, and you have this uh, this shape. So it's like a curved. Actually, let's do it like a circle. So you have this circle, but more like an oval, like an egg. Boom. So what's the meaning of each of the shapes? And I'm gonna do it really quick. So this means start or end of a program. This means processing. This means decision making. This means, sorry, this is input and output, sorry. This is processing. This is input, output. Oh, I'm so sorry. I might have done this right. Yeah. So this is not input and output. Whether it's a square or a rectangle, so whether it's this or this, it's processing. Input and output is parallelogram. So they don't have it. I'm gonna draw it. So ba 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 ba. Here we go. What does this whole thing means? So I'm gonna go and draw this program as a flowchart. Flowchart. So what's happening? I'm gonna move this all the way here. Yeah, this is good. So what's happening? What's happening is the program starts. Then what's happening? Input or output. There's an input happening and an output happening. So I'm gonna go and put this. Then there is some processing. I'm doing a process. I'm doing some processing. I'm assigning a value. So I'm gonna go ahead and put this. Then there is an input or output. So I'm gonna go and add this. Top down. Notice the top down. Let me squeeze it a little bit. Then there is a decision making. I'm making a decision. Do I do this or that? So decision. Then the program ends. So now we connect them. Now decision making always has two paths because it's either yes, do something, or no. If it is yes, what's happening? What's in the yes? There's an input and output. So let me grab another one, put it here. After the print, what's happening? Program ends. So I go back and I draw a line from here to here. And then you label it inside it. You say start. You say ask or prompt user for first integer for two integers. Assign sum, right? In the processing section, we are assigning sum. Display sum. Is sum greater than 10? Is sum greater than 10? Yes. No. Display end. So this is called a flow chart, and of course it's an arrow. So this is an arrow. 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 So also similar to pseudocode, if I come as your manager and I give you this design, I say, hey, write me this program, no matter what language you use, you're going to understand this program. You're going to understand what am I asking you to. So this is called flowchart. Flowchart. They don't mention it they don't mention it in details, but you need to know it. The next thing in the book is the if statement, which is what we saw here. So the if statement has this syntax, and between the parentheses, there's a condition that goes to be evaluated as true versus false. And this is what if statement accepts it true or false. Now, any value you give it as is, for example, like this, is some true or false. In any case, this value is true unless it's 0. So any value that is not 0 is true. Why? Because remember we had 0 and 1. 0 is off and 1 is on. So 0 evaluates to false, and anything other than 0 evaluates to true. Okay, so anything you give it here will evaluate to true, except if you give it 0 or null, which is basically evaluate as ASCII, it evaluates to 0. So this is an if statement. Let me see what do they want you. So in the book, I'm looking at the code on page 73. In the book, they did the if statement with greater than operation. So we just did that. I'm not gonna do it again. Oh, look, on page 74 and 75, they show you flowcharting. So this is what we just drew. Then they explain the else. So the same way we have an if statement, we also have an if else statement. So in this case, if this evaluates through execute. How about I want the opposite? I can do it 2 ways. I can say if sum is greater than 10, then display this. I can add another if sum is less than or equal 10, then display, right? So this condition is the opposite of this condition, because a number could be greater than 10 or less than or equal to 10. So I'm gonna add this. Sum is greater or equal to 10. So I have 2 if statements, but if I want to make the code better code and optimize it in a way that has better readability, I can write an if else statement instead of 2 if statements. And it goes just as simple as that. If, and then I type else, and then I open brackets, and then I take this same sentence, copy, paste, and then remove this. So if this evaluates to true, print this block or execute this block, else execute this block. So I put a breakpoint on this line, I execute, then I enter an integer, 5, and I'm gonna enter 8, 13. So sum is equal to 13. Is sum greater than 10? F10, step over. Yep, it's true. So this will be executed and this will be ignored. It's either this or that. Boom, boom, boom. So now I'm at 32, done. I'm gonna do the opposite. I'm gonna say 5 and 4, which is 9. So sum is 9. Is sum greater than 10? No, it's false. It's not greater than 10. Then this block will get executed. Sum is greater or equal. Well, it's less than or equal. I don't think I can continue by editing. Okay, it's a small program, so you can do that. So now sum is less or equal to 10. So this got executed and not that part. So this is the if else statement. And it's in the book section 3.6, page 74. Then they show you the nested case. So nested case means an if inside an if. For example, in this case, what could sum be? We have 3 options or 3 cases. Sum might be less than 10, sum might be equal to 10, and sum might be greater than 10. So if sum is greater than 10, then sum is greater than 10. Else, in this else, what is the two other cases? It's either less or equal. So inside this else, I can add another if. If sum is equal to 10, then I want to print f. Sum is equal to 10. New line. Boom. Else. Cut. Paste. If sum is not greater than 10 and sum is not equal to 10, so what am I left with? I'm left with less than 10. So you see what we did there? This is called nested if. So I have an if else, then an if else inside it. So if sum is greater than 10, do this. Else. If sum is 10, then print this, else print that. So I'm going to keep my breakpoint and then I'm going to run. What is the integer 5? In this case, I'm going to evaluate to 11. So sum is 11. Is sum greater than 10? Boom, yes. Now it will ignore the entire else block. And it will not display the else block. It will display the if block. Continue. Another case, I'm going to evaluate to less than. So 5, 4. Sum is 9. Is sum greater than 10? False. Okay, then we are at line 28. Is sum equal to 10? False. Then it's in the last else. Sum is less than 10. Boom, done. So this is called nested if, and it's on page 76. And they have similar example where they take a grade from the student, from the user, and then if the grade is within, if between 60 and 70, then display 60 and 70 is displaying D, then above 70 is C, above 80 is B, above 90 is A. So that's the example you have in the book, and I strongly recommend that you go after class or not even before class, and the code you see in the book, type it. You need to practice your fingers. Type it and run it, step through it line by line, see how the code is behaving, how the control is working on the code, because that's the only way it's gonna help you. Then with the book, they go with the while iteration statement. While iteration statement. It's called while loop or while iteration statement. So let me do this. So while it has this text, while it's a parenthesis, also a condition that evaluates to either true or false. So the control comes at this line. And that's just how it means. While this is true, it's gonna keep executing. So it's gonna go, that's why it's called while iteration statement, because it iterates. So it's gonna check while, is this true? If it is true, then it's gonna execute. Once it's done executing the block, it's gonna go again, check, hey, is this still true? If yes, it's gonna go another iteration. Then goes back, checks, hey, is this still true? Yes, then it goes and iterates again. Is this true? Iterates again. The moment this evaluates to false, then it's gonna ignore that. So it's no longer true, then the control will jump to this line, ignoring the entire block. Now you might be asking yourself, well, how does this change? True, 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 then false. Who changed it? Well, maybe the body changed it. Maybe inside the body, something changed it. Maybe you asked the user to enter a number, right? And that number is invalid. That number is greater than 100. Let's say I'm asking you to enter grades, right? A grade cannot be negative. and cannot be above 100. If at any point I receive, if at any point the grade is not equal or is equal, if a grade is equal -1 or less than 0, for example, if the grade is less than 0, then I stop executing. If the grade is above 100, I stop executing, right? If I can control it with a count. Let's say right now I have 30 students, right? I can control it with a count. I can say, okay, start with count equal 1. Do an iteration. Then at the end of the iteration, increment count. So now count is 2, right? And my condition would be while count is less than or equal to 30, number of students. Now in my execution, count starts as 1, then I do first iteration. Now count is 2, then I do the second iteration. So let me type 1, 2, right? Second iteration, third iteration. I'm executing a block of statements, the same number as my students. So one time, second time, for each student, the same code is being executed. 4, da. Then at the 30th iteration, the count will be set to 30, or let's say 31, because I'm done with 30. So now it's 31. So yes, then 31. At 31, count is no longer less than or equal 30. So this will evaluate to false. Then my while loop will jump. It will terminate the execution of this block. So this is how you counter control your while loop. Another fashion or another way is called sentinel. So sentinel. Sentinel meaning you are waiting for a trigger or a signal or a specific value from the user in order to terminate. For example, in any menu, I don't know if have you seen it. For example, this menu. This is a loop. This is a loop running, waiting for any key. So at any point I enter any key, it's gonna close. Now in our humble program, we can do something like this. We can say enter a grade, right? Or -1 to terminate. This is what I can display to the user. Let's say I'm computing a running total. Let's say a program that gets you your GPA. So you run that program, you start asking the user to start entering, right? Entering the grades for all the courses. Course X, I got 96. Course B, I got 70. Course C, I got 80. So you can ask the user to enter, to keep entering grade, or once the courses are done, this is the sentinel, -1 is the sentinel. So that program will start. First iteration, enter grade, boom. Is the grade equal to -1? Is the entered value equal to -1? No, then execute. Then ask the user again, hey, enter the next grade. And you check it while grade is not equal to -1. So while the grade is not equal to -1, you keep processing and asking the user. Process, ask for new value. This is basically it. This is what you're basically gonna do. You're gonna check if grade is not equal to -1, and you keep processing. So let's do it really quick. So I have a grade, int grade from the user, right? And then I'm gonna say printf, enter the grade or -1 to terminate. So printf then scanf into scanf as decimal into grade. Great. Then I'm gonna say while this keyboard sucks, while grade is not equal -1, what am I going to do? I'm gonna keep a running total. Let's say I'm not gonna calculate GPA. I just wanna give him the average, right? So I'm gonna say I have int total starts as 0, and I have int count starts as well 0. Total is 0 for now, and count is 0. Initially, they start from 0. So why grade is not -1? Then I want to do a process. I want to increment total. So I'm going to say total is equal whatever the total is plus the new grade. Then I'm going to ask the user again. Then I'm going to ask the user again. So now that I'm keeping track of my total, every iteration, I'm incrementing total. On each iteration, I'm grabbing the value of grade and adding it to total. Then I'm asking the user for a new grade. As long as this grade or the entered value is not -1, this will execute infinitely. Once the user enters a -1, then I'm gonna break out of this block, and I would like to print the average. So print f, the average is whatever the decimal of total over count. If we were in class, I could have asked you like, hey, what's wrong with this code? Or in a test, what's wrong with this code? What's wrong with this code is I'm dividing by 0. I didn't trigger count. So on the first iteration, count is 0. Then on the second iteration, count is still 0. Third iteration, count is still 0. So I need to increment. I need to say at the very end, once this iteration is done, count is equal count plus 1. So now at the first iteration, count is going to be 0 plus 1 and will be set. So now it's 1. On the second iteration, it's going to be 1 plus 1 equal to 2 will be set to 2. Then on the third iteration, it's going to be 2 plus 1, which is 3. And then, so I'm updating the value of this. Just similar to how I'm updating the value of total. So I'm going to break now here, and I'm going to run enter grade or -1. So if I enter grade -1, it's going to divide by 0 and it's going to break, right? Because it needs some safety into it. For example, I can add if statement that says if count is 0, don't do anything. If count is 0 means no values has been entered, so no need to display anything for the user. For now, I'm gonna display 90. So now it's asking me, hey, the grade is 90. Is 90 -1? No, means execute. So now my arrow is here. Total is 0. Grade is 90. So now total is 90 because 0 plus 90. So now total is 90. Print again and ask the user again. What is the new value? 80. Now count is 0. 0 plus 1 is 1. So assign the new value to count. Boom. So now count is 1. Hey, is the grade -1? No, right now it's at 80. Okay, then add it. So 90 plus 80, gonna evaluate to 170. Ask the user for a new value. So now I'm gonna say 85 just so we end it and it evaluates to 85. So now count is 1. 1 plus 1 is 2. So 2. Boom. Is the grade -1? Now I'm gonna terminate. So -1. So now I have 3 numbers. Boom. Count is 2 plus 1. So count is 3. Boom. Is the grade equal to -1? Yes, it is equal to -1. So now I'm gonna break out of the loop and display the average. Here is the average, 85, which is correct. 90 and 80 cancel each other because 10 difference. 5 is in the middle, so the average is 85. Return 0. So this is called Sentinel. Now, please, if you don't get it, shoot me an email. I can recommend you from the book or send you some code, maybe another video. But you need to learn this. You need to have solid basis of this. Because you're gonna see it in a homework, in a project, in the test, in daily life in the field. It's called while loop and both counter controlled, which is much easier. Counter controlled is just keeping track of count. So counter control is much easier than Sentinel. Sentinel is a little trickier, but I hope you guys get it. Let me know if you need help. Then we move on with the next topic from the book. And that next topic, they mention about top-down and stepwise. So top-down and stepwise, which is what we went over it. Not this, this. So top-down, how does the program execute? It executes from top to bottom, right? And you can step. So stepwise refinement means you can step with F10 and F11 in order to refine your program. You see, first, before I did this, I could have executed. And as a matter of fact, once I executed, I noticed that something is wrong. So I have a breakpoint, right? Let's say my breakpoint is here. Now I'm gonna run. My breakpoint is here. The fact that I can step in means I can refine my code, means I can check. Oh, okay, I see. It's asking to enter a grade. Okay, 90. Why it's not typing? Oh, scan F. So 90. Boom. Then the fact that I can step into, I can view. Oh, it read correct. Okay, so this line is behaving right. And total equals 0. Step over, total is 0. Oh, okay. So I can refine, I can improve my code, I can debug my code, I can tell what's wrong. I can follow the logic and notice that, for example, -1. Now that I enter -1, it's stepping out. Oh, okay, correct. This is what is expected from the code. I wanted to step over, step out. So printf, the average is total 90 over 0. Something is wrong. If I hit F10, it's gonna break. Why did it break? Integer division by 0. This is 0. Why? Oh, I see. Because I initialized it as 0 and I didn't change that value. Where should I change that value? Oh, inside the while loop. Every time I'm done, with the code, I need to say that my count has changed. Okay, I refined my code, I debugged my code, and now it's working. Then I think we are done for now. Later we're gonna see if else inside the while, and we're gonna learn about increment and decrement operators. And this should be it. Thank you, everyone, and talk to you soon. Take care.